This is problem number 10 for section 2.3. In this problem it says Ohm's law for electrical circuits, like the one shown in the figure, states that V equals Ri. So we're going to kind of write that out here. V equals Ri. In this equation, V is the constant voltage, I is the current, R is the resistance in ohms. Your firm has been asked to supply the resistors for a circuit in which V will be 120 volts and I is to be 10 plus and minus 0.5 amps. In what interval does R have to lie for I to be within 0.5 amp of the value IO equal 10? Okay, let's draw this out for what we've been doing. And this chart is going to be a resistance versus the current chart. They want the current to be 10, and they want, and I'm just going to draw a line because this is just a representation of what we're doing. We have some constant here, and they want the, sorry, we're going to put the constant right here, and they want the values, so this is the R value. They want the values for the current to be within 0.5 amps. So that's the epsilon here. This is 0.5 amps, and this is 0.5 amps. So here's what we've got. We've got L equaling 10 amps. We've got epsilon being 0.5 amps. We've got a function which is V equals Ri, right? So we need to go through, we need to find out what are these values here that will keep us within this range. So we're going to start with the absolute value of f of x. Absolute value of f of x minus L. And it has to be within 0.5. So if we want to start there, we're going to have to plug in and we're going to have to say absolute value of f of x minus 10 has to be less than 0.5 amps. So we need to figure out what's the function value going to be. Well, we want this function value to be in terms of, we want it to be in terms of I, because that's what we're dealing with, right? So we're dealing with amps. So if we take this equation and we rearrange it so it's I equals V over R, we can take this V over R equation and plug it in for f of x. So we have absolute value of V over R minus 10, absolute value is less than 0.5. Now we already know that the voltage that we're being supplied is 120 volts. So now we can plug in absolute value of 120 over R minus 10 is less than 0.5. And now we just need to solve this like we've been doing to figure out our values for the resistance. So we need to figure out what's the lowest and what's the highest value, because they're asking us for basically the system requirements for resistance. So we're going to say that 120 over R minus 10 equals 0.5, or 120 over R minus 10 equals negative 0.5. Add the 10 over, we get 120 over R equals 10.5, or when we do the same thing over here, we get 120 over R equals 9.5. We're going to flip each of these, so we're going to get R over 120, right? This is just an algebra move. We flip this side, so we'll flip this side, 1 over 10.5, or Flip this side, you get R over 120 equals 1 over 9.5. Last step we're going to do is we're going to take and multiply by 120, so we get R equals 120 over 10.5, or 120 over 9.5. When you do 120 divided by 10.5, you get an R value of 11, and I'm going to kind of write this a slide up. We'll just write it as 429. And then a value here, 120 divided by 9.5 of 12.632. So our value here is going to be 12.632, and our value here is going to be 11.429. Now we know we need to be between these two resistance values because our C value has to be inside of here in order for us to produce this current value of 10. So what does that mean about the company's resistors? The company's resistors have to run from, so the company's resistors must produce a resistance between 11.43, and they'd call this ohms, and 12.632 ohms. And that's the answer to the problem. Recap of it, we started with the amps. We used that same equation, the absolute value less than epsilon that we've been using. We plugged in our function, which we had to rewrite as V over R, along with our amps, which was our L, and our epsilon. We plugged in the voltage, and then we just solved the absolute value to find our interval.